We'll investigate our next law of exponents by simplifying this expression. So we're going to follow order of operations, exponents first before the multiplication. So 6 cubed, 6 times 6 times 6 is 216. 6 to the 5th power is 7,776. And when we multiply those two answers together, we will get 1,679,616. Now take your calculator and evaluate 6 to the 8th. And we get the same exact answer, 1,679,616. So if this expression, 6 to the 8th, gives us the same answer as 6 cubed times 6 to the 5th, you should notice here the beginnings of our next law. If our bases are the same when we're multiplying two things together, you can keep that same base and simply add the exponents together, and it will be equivalent. So that's our next law. So take your next index card, and we'll put this down. X to the something power times x to the something else power will be the same as doing that base of x to the something plus something else power. Flip your index card over. We'll do some practice with this law and maybe a couple of the others while we're at it. Here's our first one. X to the 4th times x to the negative 11th. Bases are the same. I am multiplying, so I can keep that same base. And when I add 4 and negative 11, I get negative 7. Now, we can simplify this further because we have our second law that says anytime I've got a negative exponent, that's the same as doing the reciprocal of that base to the positive 7th power. Next problem. X to the 4th times y to the negative 11th power. Hopefully you're saying there's nothing we can do here. The bases are not the same, so we cannot multiply them together into one single entity. It stays x to the 4th, y to the negative 11th. Next one, x to the 4th plus x to the negative 11th. Nothing to do here either. This is the answer. Because we are not multiplying those x's, we are adding them. And to add things together, you need like terms. And x to the 4th and x to the negative 11th are not like terms. Next one. Now let's multiply 3x squared and negative 4x cubed. So I've thrown in some coefficients here. But the coefficients we just do as normal. 3 times negative 4 makes negative 12. And then our bases of x can stay in x. And my exponents, 2 plus 3, will make 5. And lastly, here's a long one. 5x squared, y to the negative 4th, z to the 8th. That monomial times this other monomial, 7x to the negative 4th, y to the 6th, z. In order to multiply all that together, let's start with the coefficients. 5 times 7 makes 35. Now, each letter we're going to take separately. X squared times x to the negative 4th is going to be x to the negative 2. Next variable, y to the negative 4th times y to the 6th. Negative 4 plus 6 is positive 2. And the z's, z to the 8th times z to the 1st will make z to the 9th. Now you should spot in there that that x is a negative exponent, so that would be the same as doing 1 over x squared. And then if I wanted to write that all as one entity there, my 35, my y squared, my z to the 9th would all be in my numerator, and that x squared sits down in the denominator.